So you might have heard about hereditary or ancestry test, and there was a company who got FDA approval for that was 23andMe, which is, I think, I'm not sure, but it was a subsidiary of a very big company. But yeah, so what they do is they will send you the kit at your home. You just take a swab from your mouth, or if they need not the blood sample, I think it was the swab, you can just send it back. They will run your genetic test. They will run for the markers. They are not allowed to do genetic test, I think, but they run for the markers, and they can have your ancestry, genetic ancestry ready. The again, in a lot of cases for paternity testing, this NGS is involved. So you can check for the origin uh, in the dispute between father and mother. For a child, you can check the paternity also. Then compatibility test is nothing but a genetic screening before marriage, which is not very popular right now. Genetic fingerprinting is again is kind of genotyping the species. Genetic disease risk we already talked about, and then personalized medicine. Talking about personalized medicine, let's go ahead and see what are the things. So here you can see, just it's just an example that if you take a human blood and take a DNA out of it, you isolate the DNA from human blood and you just sequence it using the sequencers. After getting the sequence, what will you do? What are the things available for you to analyze it? So it basically depends on the question, what question you are answering. Let's say you are answering, you are trying to find a variant, you will go for a variant calling pipeline. If you are trying to find out which genes are overexpressing or underexpressing, you will go for transcriptomics, RNA-seq. It could be small RNA or RNA, anything. What proteins are binding to the regions, what regions of the chromosome is open. So there are a lot of things you can do while once you have the sample with you. So so this is what you all is, you can do personalized medicine. You can find out the cause for any disease. You can just, and this is again, both are the diseases. You can do genetic testing for biomarkers or the SNPs, the markers for genetic, rare genetic diseases, or the diseases which potentially can harm your future. You can again make the personalized medicines. You can sequence, you can discuss it with clinicians. You can, for well-being of a patient, or yeah, for well-being of a patient, you can provide them a better life by doing all these things. You can make a personalized medicine for them, which will only affect them and not others. So this is how the, it's a very general view. There are a lot of work in between this, but I am trying to simplify it. So you take healthy individuals and patients, the samples, and you run there, and you extract DNA out of them, you sequence it using second generation sequencers or third generation sequencer, you do genotyping, and then you try to focus on the problematic regions in the genome. It could be non-coding, reasons, it could be coding reasons like in exome sequencing. So, and then you try to interpret the data. After that, you will discuss it with clinicians, genetic counselors, and doctors. They will come up with, and you will tell them what you found. What, so when we call variant classification, somebody asked me, so I will try to clarify that you will not get only 2 or 3 mutations, but you can get thousands, hundreds and thousands of SNPs, the changes in the genome. And it's not feasible to check all those hundreds and thousands of variation in the genome. So how will you narrow down to, let's say, top 10 or top 100? So that is also one study. So when you when you use GATK pipeline and you call for variants, it's not that it will give you only 5 variants or 6 variant. It's very highly unlikely. You will for sure get a lot of variant. So then again, there is a field where you will go and try to narrow down using integrating lot of other stuff, lot of other high throughput data, and then you will discuss it. The clinician researchers, they will try to come up with a personalized medicine for that person only. Right now it's very costly affair, but I think with future, just like genome sequencing, the rates dropped, the personalized drug therapies will also see a market with very cheap alternatives.